Assalamu alaikum warahmatullahi wabarakatuh. This is going to be, inshallah, the first video in a group of videos that is going to discuss SAAT physics exam, which is tahsil exam. And I hope that everyone gets benefits out of this video and the rest of the videos, inshallah ta'ala. We are going to go through group of past paper questions in SAAT physics, through which these questions we are going to revise uh, basic formulas, fundamental concepts, and we are going also to revise some of the work of the scientists that made great participations in the field of physics, right? So let's start. Bismillah ar-Rahman ar-Rahim. Question number one says that one of the basic physical quantities is, right? Now, we need to understand the following, right? Physical quantities in physics are classified into basically two categories, right? So we have um, basic physical quantities and we have derived physical quantities, right? Now, in order to understand the difference between them, a basic physical quantity is or can be considered as an original physical quantity, while a derived physical quantity is not an original one. It goes back to one of the basic physical quantities. So, speaking of speed, for example, right, let's get back to the units in order to identify whether this physical quantity is basic or derived. Getting back to speed unit, the speed unit is meter per second. Length unit is measured in meters. Force is measured in newtons. And energy is measured in joules, right? Now, Newton is not the physical quantity or the physical unit, right? It is derived from another unit, which is kilogram meter per second square. This comes from Newton's second law of motion. On the other hand, a joule is the same thing. Joule is derived from kilogram meter square per second square, right? So as you can see here, three of them, they originate from whether kilogram, that's for mass, length, or time. The only one which is a basic physical quantity is length, right? So the answer here is length. Okay, this is for the first question, right? Now going for the second question, the point at which two variables are equal to zero is named, right? Or what is it called? Now, this is an easy part for physics and in math as well, right? If we have an x and y axis, the point at the origin, which is right here, where all the variables are equal to zero on the y-axis and on the x-axis, right? This point is called the original point or origin point or point of origin, where all the variables are equal to zero, right? So here, this is an easy question. The answer is D, right? The origin point. Next, if an object is placed on a horizontal surface, the direction of the normal force would be, right? So let's see this one. We met previously so many types of forces. We're not going to go through all of them now, but we are going to discuss specifically the normal force. Normal force is the force applied on an object when the object is placed on a horizontal surface. So for example, if I have a box and this box is placed on a horizontal surface, as you can see here, this box now is affected by mainly two forces. One of them is called Fg, that's the gravitational pull downwards, and the other one is Fn, which is straight upwards, right? Now, if we go back to Fn, we will notice that Fn makes an angle 90 degrees with the surface. That is why it is called the normal force. So if the object is placed on a horizontal surface, the direction of the normal force would be upwards, straight upwards, right? Just as a quick hint for everyone, what if the surface is inclined like this? In this case, and here's the box, in that case, the normal force is still perpendicular to the surface. However, Fg is always pointing straight downwards. Don't forget that, right? So here the answer is A because we are dealing with the first drawing, this one. Okay, so the answer is A, upwards. Next question, a train covers the distance between two cities in 200 seconds while the speed is 40 meters per second. The distance between the two cities is, right? Okay, this is a simple substitution formula, right? We know that speed is equal to distance over time. So rearranging the formula gives us that distance is equal to speed times time, right? Which gives us 40 times 200, and that would be 8,000 meters, right? As a quick hint, guys, for everyone, units should be consistent with each other, right? Which means that when the time is given in seconds and the speed is given in meters per second, the length unit should be given in meters, right? So please make sure before going through any calculation that the units are always consistent, right, with one another. So the answer here is 8,000 meters. Next question. The impulse on an object affected by a force of 25 newtons for 2 seconds is, right? Now let's see this one. Here, impulse is defined as the force applied over a given time. Force times time. It is one of the vector quantities, right? And its unit is Newton second, right? So here, also simple substitution. So that would be 25 times 2, which is 50 newtons second, right? By the way, one more point, right? Impulse is defined also as or can cause a change in momentum. Change in momentum. So accordingly, right, the Newton second is equivalent to kilogram meter per second for momentum, right? So here the answer is B, 50 newtons second. Okay. Question 6, the boiling point of water is, right? Now, I think everyone knows that the boiling point of water should be 100 degrees Celsius. So the first thing you should check is A, right? But the problem here is it's not only A, right? The temperature in Kelvin is equal to the temperature in Celsius plus 273, right? So here the boiling point of water in Kelvin would be 100 degrees Celsius plus 273. So that would be 373 kelvins, right? So choice A is correct, choice B is correct, right? What about choice C? Well, you don't know whether choice C is right or wrong, right? But the point here is there is a choice D that says that all the previous answers, right? So since that A is correct and B is correct, so the choice here is D, even if you're not sure of the answer, but two choices out of three choices are correct, so D is most likely to be the answer, right? So it's all of the previous answers. Question 7, body spray depends on whose principle, right? Is it Bernoulli, Pascal, Archimedes, or Newton? Of course, those are very famous scientists, right? And each one of them has his own participation in the field of physics, right? Just a quick review for their main let's say main profession in physics, right? Bernoulli was concentrating on the pressure and fluids generally, the fluids motion and so on, right? Archimedes was relating density and floating. Of course, this was not his only participation, but these are the basic things that he is famous for. Pascal, that is pressure generally, and Newton, he was relating motion and forces, right? Specifically, the body spray depends on Bernoulli's principle, right? So the answer here is A. Last question in this video, the spring constant of a spring storing potential energy of 8 joules and extends for 0.2 meter would be, right? Now here, as you can see, there are some givens that are given to you, and all what you need to do is to rearrange and to deduce or guess what formula should you use, right? So here we have potential energy stored. So this is discussing the elastic potential energy, right? A quick review for the elastic potential energy. PE elastic is equal to half kx squared, right? Where k is named after the spring constant and x is the extension. This is the extension and this is the spring constant, right? So if we are looking for the spring constant, all what you need to do is to rearrange the formula that the spring constant k is equal to 2 times PE elastic over x squared, right? Doing this calculation, you might think it's hard, teacher, right? How would we do that, right? Let's see how do we do it. So it's going to be 2 times 8 over 0.2. Okay, so how do we do this calculation, right? First of all, how about this? Let's convert the 0.2 into 2 out of 10, right? And don't forget that this is 0.2 squared, right? So rewriting the formula again, it becomes 2 times 8 divided by 2 over 10 squared, right? So that would be 2 times 8 times 100 over 4. So what I did now is I flipped the 2 over 10, I found the reciprocal square, so it becomes 100 over 4, and I changed the division symbol into multiplication, right? So now it's easy. 2, 4, so the answer would be 400 Newton per meter. Okay, of course, with more practices, you will be able to do this in a quicker or less time, right? So the answer is 400 newtons per meter. Thank you for watching this video. Don't forget to subscribe in our channel and watch the rest of the videos, right? This is going to be, like I said, the first video of a group of videos that dealing with uh, SAAT or تحصيلي physics past paper questions. Thank you for listening and have a nice day.